So we're going to plug in negative x. So you have f of negative x equals 2 negative x plus 5. So you get negative 2x plus 5. So is that the original? No. So not even. Take out a negative 1. Is it negative 1 times the original? So not odd. Therefore, f of x is neither. So it's not that it's not a function. It's just not symmetric. So it just doesn't have any of those symmetry properties. Some functions have single formulas. Some functions have multiple formulas. So when a graph goes from one function to another, we call it a piecewise, because we are piecing together multiple functions. So it's called a piecewise because you're piecing together multiple functions. So we have 2x minus 1 and x squared plus 3. So 2x minus 1 is linear. X squared plus 3 is quadratic. So we have a good idea of what our graph should look like. We should have a line and a curve. The breaking point is at 0. So that means to the left of 0 is the linear, to the right of 0 is the quadratic. In calculus, we really like when they overlap or meet each other because that makes them continuous. If they don't overlap or meet each other, then they have what we call discontinuity. And then they're discontinuous and we can't perform certain math to them. So let's look first at the linear. So it's 2x minus 1. So what's really nice is since the breaking point is at 0, I can plot my y-intercept. So my y-intercept is negative 1. This is equal to 0, therefore it's a closed point. So I have a closed point at negative 1. And now I just apply my slope backwards. So forward would be up to right 1. So backwards is down to left 1. So the line is still increasing. The range of that line would be all y values from negative infinity up to negative 1, including negative 1. So the domain is x less than or equal to 0, or negative infinity to 0. The range is negative infinity to negative 1. The quadratic is shifted up 3 units because of the plus 3. It is an open circle because it's x greater than. And now, from the vertex point, you just apply your perfect squares rule. So usually it's 0, 0, 1, 1. Well, now it's 0, 3. So instead of 1, 1, it's 1, 4. Because it's shifted up 4 units. So it goes from 1, 1 to 1, 4. The next point's 2, 4. So it would be 2, 7. Or, yeah, because 4 shifted up 3. And then technically the third point would have been at 3, 9. But now you've got 3, so it's 3, 12, we're still on the screen. So you just take your quadratic and shift it. And that's that table I used to do with you. I really hated it. That makes sense. Okay. So, do they connect? No. Is this continuous? No. So my range is broken apart. So this one ends at -1. This range starts at 3 and goes to infinity. So there is a gap in the range, therefore can't be continuous. Absolute value functions are a special type of piecewise function. An absolute value function is a special type of piecewise function in which the graph has a positive slope to the left of the vertex and a negative slope to the right of the vertex. So an absolute value is actually just a piecewise with opposite slope values. The parent absolute value function is considered even. The parent absolute value function is considered even, which is very kind of unique to me because I feel like x is linear, which is odd. So you automatically like have this odd vision in your mind, but the parent, I feel like that's also like an SAT like trick question. I feel like they always kind of ask like, is the absolute value of x even, odd, or neither? And I feel like you want to just auto put odd, but it works out algebraically to be even. And you can see it even in the graph. So solve the inequality and then graph it. So the inequality, again, these are on your handout. The absolute value of 3x needs isolated. So first move is to move over the 4. So you get 12. Then you go to the point where it's like, okay, so the absolute value has to be split because you can have the positive or the negative. So 3x must be greater than 12, or 3x is going to be less than -12. So essentially the inequality switches directions because you changed the sign. And when we divide or change the sign, it becomes negative. And you change your inequality. So you get x greater than 4, or x less than -4. So it's an or, because they're going in opposite directions. It also started as the absolute value was greater than 12. So on a number line, which we're not going to graph the v because I didn't put in a y, so it kind of gets messy. But essentially, this is going back to your domain and range, being open and to the left and open and to the right. So in terms of a graph, it's kind of going to have that more pretty V shape because it's going to have a gap in the middle. Last new thing we're going to talk about today is composition. Composition is the f of g or g of f. It's your fog, your goth. If you throw the h in there, you got your hog. So f of g or g of f, it means you are taking one function now and replacing the inputs of the original function with a function. So you're changing the inputs of the original to be a function inputted into a function. When we do this, those functions have to take on each other's domains and ranges. So if the domain and range of f and g are both all reals, then the composition is all reals. But if g had a domain greater than or equal to 0, and f had a domain of all reals, well now f of G's domain is probably going to be x greater than or equal to 0. Or a new domain in case it's shifted or translated at the end. So when you do composition, you have to take into account a new or final domain change. So f of g is the same as f of g of x. You could also see this written as f of 5x. So instead of having g of x in there, they might just totally plug the function in there. And that's 2. Everywhere you have an x on f, you replace with 5x. And then you simplify. We can do the opposite. And it's important to note that f of g of x and g of f of x are not equivalent. So plugging g into f and f into g does not give equivalent. They are usually differing. One time I said that in one of my classes, I ended up making the same. I was like, well, that was just a lucky example. So you can see here similar slopes, but different y-intercepts. Okay, so homework is in our book. You can change this, we'll change it to odds. That way you can check them again. Now I believe, and I will check it, I believe the 37 to 40, I think they're matching. So I think you have to do the whole group. That's why I got my book. Because again, this was the old textbook, so I want to make sure it totally matches our new. I was good about the one problem changing it. I was like, confirm. And if I change it, let's see. Yeah, definitely. Okay, section 2. Yep, so 129 odds works out perfectly. And like I said, the 37 to 40, they do kind of group together. I just have to add 2 more problems. 51. I think you should have success with 41. I think like 2 more. Alright, so 41, I'm going to do 42 kind of real quick with you. They want you to write a piecewise. So we went over how to graph a piecewise. So you're kind of doing it in reverse. So if you had a function given to you, so like in 42, it has 4 parts. So you should have 4 piecewises. So the first piecewise goes from 0 to 1, where it includes 0, but not 1. So it'd be like 0 less than or equal to x less than 1. And then because it's horizontal, it's just a number. So it's the number 2. If it's a line, which is what I gave you in 41, then you would apply like the slope of the line and the y-intercept. So your 41 will have 2 parts, where like 42 has 4 parts. And you just have to show the breaking points and the slopes and like find the slopes of the lines and like write their equation. So like 42 is going to go back and forth between 0 to 0 and 2, and then just manipulating between them. Yeah, I'll do it. So 41 should be okay.